So AI coding assistants are pretty much everywhere now, right? And they are unbelievably fast. But here's the thing, that speed can be a double-edged sword. Without a really strong plan, an AI can create a tangled mess just as fast as it can write clean code. So today, we're going to dig into a framework that helps you harness that power, using structure to turn AI from a chaotic force into a seriously disciplined partner. And this really gets to the heart of the matter, doesn't it? Are we just churning out more lines of code faster than ever before? Or are we actually building systems that are more robust and easier to maintain? The answer really depends on how we choose to guide the AI. So let's talk about this paradox. On one hand, AI gives us incredible speed, but on the other, without any direction, it has this tendency to just blur responsibilities. It creates this tangled web of hidden connections between all the different parts of your software. And that's the core challenge we've got to solve. Right. So the problem isn't the AI itself, it's how we're using it. The real issue is that an AI has no deep understanding of the overall system architecture. It's fantastic at the tiny little details, but it needs clear, firm guidance on that big picture. This all leads us to a really powerful new way of thinking about our work. Think of it as a partnership. The human, that's you take on the role of the architect. You design the blueprint. And the AI? It acts as the executor, handling all the hands-on construction work. In this slide, it just lays out that division of labor perfectly. Our strength as humans is that high-level thinking, system design, architecture, making those complex trade-offs. The AI, on the other hand, is an absolute powerhouse for implementation, writing tests, and doing research. This partnership lets us offload all those repetitive tasks so we can focus on the big picture. Okay, so if we're the architects, what does our blueprint even look like? Well, we need a clear, structured model that can serve as a solid set of instructions for our AI partner to follow. And here it is. This is the core of the framework. It's a hierarchy, a set of boundaries that goes from the entire system all the way down to individual classes. This structure, this is the key to keeping control and making sure everything makes sense as the AI is generating all that code. All right, let's start at the top. The package. Think of a package like a self-contained unit with one and only one job. Maybe it handles user authentication, or it processes payments. The single most important rule here is that it only talks to other packages through official, predefined channels, no backdoors. And that official channel, that's what we call the public surface. This is the formal contract, the API that a package shows to the rest of the system. It's kind of like the front door of a building. It's the only way you're supposed to get in and interact with what's inside. Now, everything else inside that package, all the messy, behind-the-scenes machinery, that's all considered private internals. And by hiding these details, we give ourselves the freedom to update or completely refactor the inner workings of a package without breaking anything else in the system. As long as we don't change that public contract, we're golden. Okay, so we've laid out the blueprints, but why is enforcing these boundaries so absolutely critical, especially when you bring an AI into the mix? This is the perfect way to think about it. These boundaries are guardrails. They keep the AI focused. They stop it from veering off course, from making its own assumptions, or from creating all these messy, unspoken dependencies all over your code base. They provide the constraints it needs to actually be effective. And the benefits? They're immediate and they are powerful. When you enforce these rules, you stop that slow erosion of your architecture. The code the AI writes suddenly becomes predictable, which makes it way easier to review. Your system stays modular and flexible, all because you've stopped those accidental tangled dependencies before they can even form. And this is such a crucial insight, one you learn from experience. You have to be explicit. You have to spell it out. An AI, if you let it, will just grab the most convenient tool for the job, even if that means reaching deep into the private guts of another package. We have to lay down the rules of engagement, loud and clear. So let's put this all together. How does this actually change your day-to-day work? Well, it becomes this clear, structured process that really leverages the best of both worlds, human creativity and machine intelligence. Okay, so here's how this collaboration actually works in practice. First, the human architect, that's you set the plan. Second, you define those package boundaries and the public contracts. Third, you can use the AI to speed up research. And fourth, here's where the magic happens. The AI implements the code and the tests, but always within the guardrails you've already built. And finally, you, the human, review the result, not just for bugs, but for whether it fits into the grander scheme of things. Look, if you take only one thing away from all of this, let it be this. With AI-assisted development, you absolutely cannot make up the architecture as you go. You have to define the structure, the boundaries, and the contracts before you let the AI start generating code at scale. And this brings us to a really exciting final thought. When we offload all that painstaking work of implementation to our AI partner, it frees up our time and our mental energy to just think bigger. So the question isn't just about how we build anymore. It's about what new, more ambitious, more incredible systems we can now dream up and architect.